generative AI? What are the risks and opportunities that it provides? Because, you know, even before we delve into AI, I mean, generative AI, what is AI in broader terms? So before we learn, I'll just, introduce you some of the terms that are being frequently used. Uh, So hi, I'm Srikanth here, and let's take a deep dive into the nuts, bolts, and the screws of generative AI. Okay. Uh, so this is the agenda. I'd like to cover these following: what is artificial intelligence? What is generative AI? How does Gen AI work? Opportunities and the risks. Okay. So uh, ever since ChatGPT was released, right, last November, if you look at this, this is a sheer scale of all the applications so far that had changed the landscape of communication and social media. So when it is Netflix, which is at the top, launched in 1999, it has taken 3.5 years almost for it to reach a million subscribers or a million signups. So on and so forth with a lot of other applications like Facebook. It had taken 10 months. Instagram, it has taken 2.5 months. But when it comes to ChatGPT, it had just barely taken 5 days for a million users to try out the conversational abilities and the general Q&A that it had to offer. So now it begs a question that can we know how it works? Do we know how it works? If yes, what is under the hood that happens? So before we get into that, what is artificial intelligence? So it is nothing but this is again a Wikipedia definition: the simulation of human intelligence processes by machines. So basically, whatever you would do in an on a daily basis, right? Be it a repetitive tasks, or be it some creative tasks. When a machine does it, that's where you have artificial intelligence, right? So this map would like to give you a gist of where we stand at right now and what is the future like. So what is the big deal about artificial intelligence? I mean, there are so many innovations, so many technologies that have come in, be it cloud computing within IT domain itself, be it cloud computing, be it about big data, so on and so forth. What is so different with AI? Okay, that is because it is classified as a general purpose technology. What is general purpose technology again? A technology which can touch lives of millions and billions of people all around the world in their day-to-day life. Like, for example, if you look at the top 25 general purpose technologies, right? You would see the discovery of fire, invention of a wheel, light bulb. Yeah, so light bulb, electricity, steam engine, the first printing press, the first calculator, and then the computer. These have crept into our daily lives so much that it impacts us basically, to a large part, optimizing our work. So AI is one such technology which is general purpose. And, prior to March this year, okay, we were at the beginning stage one, which had like machine learning at the core, right? And after that, what happened was in the month of March 13th, if I'm not wrong, this year, GPT-4 was introduced by OpenAI. It changed the game. It captivated not just those in IT, but it captured developers worldwide. Because we are, although it is at its infancy, it shows the sign of early intelligence, early AGI, artificial general intelligence. What is the difference between ANI and AGI? Okay, ANI is artificial narrow intelligence, which means that it is task specific. Like, for example, you have a robot in your home, right? That sweeps the floor. Okay, it does its task. it is done for the day. Okay. Similarly, there are robots which does the paint job in car factories, right? They are designed for that task. They do it and they are done, right? These are task specific robots. But a general intelligence machine would not just mop the floor, it would also clean your dishes. It'll prepare your breakfast. It'll sing songs to, sing lullabies for you to take you to sleep. So that is a game changer. That is a game changing technology. That is something of a bearings that has on every domain. So that's why uh, general intelligence or artificial intelligence is a general purpose technology. Then what is generative AI? Okay. Again, the definition is that an AI algorithm that uses deep learning techniques and massively large data sets to understand, summarize, generate, and predict new content. So in a nutshell, that's what it is. But then in layman's terms, right, it generates something. Okay, it generates new images, it generates words, it generates stories. It can even synthesize your voice and then have a conversational flow based on your voice. So how does that work? I mean, it is amazing because when you're being asked only about like for example chatbots, right, like IRCTC website or some banking website, you say that you have an issue, then it says that please pick the following options for A for your bank issues, B for your credit card issues, so on and so forth. There is not an explicit conversational flow that's happening, but generative AI especially with GPT-4, right? It can have the conversation. So it feels like you are talking to your friend, right? So it captures the context and gives you the relevant answers. Before we dive a bit deeper, this is a map of what AI, data science, machine learning, deep learning, so on and so forth entails, because these are often used interchangeably, right? So, again, if you take a bit deeper, deep dive, so there is the machine learning. I mean, again, machine learning is a subset of artificial intelligence. Then there is machine learning. There is a subset of machine learning called deep learning. And there are coinciding subsets of the deep learning called large language models and generative AI. Apologize for this word mess up here, but this reads large language models. Okay. These are the players, both big and small, which are offering commercial and open source LLM to us. So we must be all familiar with OpenAI, but there are many others which you can try out. But this is the application landscape of basically a lot of platforms which offer SaaS applications based on the LLMs, large language models. Now, these are not just restricted with text, but they are into video, they are into audio, images, code, and medicine, so on and so forth. Okay. Just a brief timeline of how AI evolved. So 1947 was when Alan Turing talks about, the machine, the device he had invented. And so the coin that was termed after that, the Turing test, right? Essentially what it does is that it examines whether a machine is a human or a machine. So basically it it basically used as a test to identify between a man and a machine, right? So, I mean, if you look at the progress, OpenAI and other competitors are there as of now. Let's look at the large language models. And if you notice, right, on the left bottom corner, you have an image which is generated by Midjourney. Now, Midjourney is another SaaS platform. Now, what is the difference that GPT has over ChatGPT, right? In terms of the sheer number of parameters that it has, almost 1 trillion, okay? And GPT-3 was about 173 billion. Now, if you visually see it, you can see almost like 4 to 5 times of competence in terms of how GPT-4 delivers. Okay, so that is the sort of capability we have. Now, what does that have to do in real life competitive exams, for instance? If you look at this, this is the scores that GPT-4 had, performed in some of the toughest exams in the world, right? These are pretty impressive. I think not all students, or not even the topmost students, would be probably able to score these kind of scores in these exams. Okay. Now, what are the different types of LLMs, right? Because I think on a higher level, it feels like, okay, large language models, and it has so many utilities. But if we classify them, you can do it based on how they work, right? Zero shot, fine tune, and multimodal. What they do is basically zero shot is nothing but it's a general purpose LLM. It can do translation, it can do word suggestion, so on and so forth. And the next one would be domain specific. Now, when I say domain specific, what I mean is like the zero shot LLM is more like the one which you see there at the top. It's a dog that you may have at your home. So all it does is basically follows your instructions, right? It is not designed to be to perform specific tasks, right? However, when you are looking at a fine-tuned model, it can deliver specific tasks. It can do, like, for example, image generation, for example, audio synthesis, right? So these are models in LLMs that can deliver specific tasks. Before I start this, I just want you to caution that this can be a bit delving a bit into the mathematics of it. So I warn you not to go into a slumber. I'll try to make it as interesting as I can, but please stay with me. You would love it. Okay. How does AI, or for that reason, how does machine learning or data science, differ from a traditional program? This is a very simple program of labeling a cat. So based on what do you say an animal is a cat? It needs to have 4 legs. It needs to have like 2 ears. It needs to have fur, so on and so forth, right? Attributes. Does it mean that any animal that has 4 legs and 2 ears and has fur is a cat? No, of course not. The distinction goes much beyond that. Like the size of it, the weight of it, the color, the mane of it, or, I mean, the more you delve into it, the complexity goes exponentially. Okay. So what we've been doing since 2012 up until last year is that we used to give cats, dogs, humans, autos, aircraft, missiles, etc., plants, so on and so forth. So we used to basically label them and train the models to understand that, okay, a dog would look like this, or cat would look like this. These are the attributes. This is how an apple would look like. This is how an orange would look like, and so on and so forth. And at the end of the training, we used to pass an image asking it, can you guess what this is? And it would say, yes, this is a cat, or this is a dog. Fair enough. I mean, we are happy there. But can we do better? Yes, we can. How do we do it? So how about easing this process? A matter of fact, this is one example that I probably mentioned. So we were working on an image-based segmentation for websites, right? The challenge there is that you need to annotate a lot of these elements, HTML elements. So a lot of manual work there, scrape the data, do annotations, train the model. It's a bit lengthy. Is there a better way? Is there a better way when it comes to language? Is there a better way when it comes to audio or images? Yes, there is. And what is that? All you need to do is just, give a pile of books to the model and let it understand by itself what a cat looks like, or what a particular answer to a question, how amazing would it be? So that's where we stand it right now. So here is where one example. So this is a poem from one of the authors. Sorry, couldn't remember the name. But the verse says that early one morning, the sun was shining. I was laying in bed, wondering if she had changed at all, if her hair was still red. Amazing poem, right? It was about a woman. And, if you look at the words, right, bed, red, and it could be, rhyming and it would sound beautiful. Can we use this sort of sentences and predict the, let's say, the continuity of this poem? Can we do that? Let's see. One way that we can achieve that is by, finding the commonly occurring words. Like in this example, was is one occurring word, and there's also the word if that is occurring at two locations, right? So what we do is we group them together, make a tree of it, and then see if you traverse from left to right, right? So once you group that, it has 0.33% of probability, the proportion of the occurrence, and 0.5 for each of the if words, right? Now, if you traverse from the left to right, early one morning, the sun was laying in the bed, sun is laying in the bed, which is not sensible, but it's still okay. Early one morning, the sun was shining. Shining. So I wondering if she had changed it all, so on and so forth. So the point is, if you are traversing, you will most likely end up in the original sentence. But if you traverse a little differently also, the sun was still red. This is fairly meaningful sentence. Her hair was shining. This is still a meaningful sentence. But is that all? Of course not. If you traverse in a different direction, it ends up giving something like this. I was shining, I was still red. Now this doesn't apparently make any sense, right? So how do we solve this problem? Okay. Before we delve into how it would solve the problem, what it was doing in the previous instance is that it was assuming that the word was is dependent on sun, or the word laying was dependent on the previous word was, right? The word her is dependent on if. Basically, it is just guessing for the word based on the previous word. Okay. So mathematically, how do you write it is the probability of the current word, with respect to the previous word. Okay. Now, can we do it a little better? Yes, we can. Now, instead of depending only on the previous word, let's take two previous words. Okay. Now, then you will find a list of trigrams. So if you read this word, early one morning the sun was, so on and so forth, you have a list of trigrams in this 25 worded sentence. Okay. Now look at this equation. The equation got a little bigger when we consider trigrams, which means that the word prediction depends on the previous two words, right? Now, this is just one verse from a poetry. Okay. Here, you want to predict the word red, right? So if you want to predict the word red, how would you basically go about it? It becomes a very complex task. Now, there can be so many probabilities, and the probability for this word, this verse, early one morning, blah, 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 was still red. That sentence has a probability of having 10 to the power of 70 combinations. So the sheer size of just permutations and combinations with just this sentence is simply incomprehensible to basically train any model. Can we solve this? There is the magic. So this is the representation of an artificial neural network. That is a 2D representation, but in real terms, it would be something like this on a 3D model. So what is so different about artificial neural network? Okay, before I talk about artificial neural network, there are some function approximations, like for example, Fourier transformation, right? So what they do is these are approximation functions which can fit in a complex equation and then help you solve it. Okay. Artificial neural network is one such approximation function for tasks like text and images. Okay. These are the parameters, these are the concepts which power artificial neural network. The first one is gradient descent. I mean, this is like the most fundamental and important thing in artificial neural networks. The next one is backpropagation. In simple terms, what this means is that the gradient descent algorithm tries to minimize the cost function. Matlab, let me just put it this way. You're going to buy a house, right? You're going to buy a house in, let's say, Bandra. Okay. I'm not very well versed with Mumbai, but then let me just dare and take an example. So I want to buy a house in Bandra. So I expected some certain price. Okay. But the price is too much, right? So I need to sort of model the prices depending on a particular area. So what do? I gather all the details, right? What is the house price on an average in Bandra? How is it in Virar? How is it in XYZ places? What this gradient descent does is it tries to generalize and decrease the cost function as much as possible, so that when I go prepared with cash in hand to buy a house in Bandra, I'll not be so shocked that, oh, I expected this to be so and so, but this is 5 times my worth. So that is what gradient descent does. And how does that do? It works based on backpropagation. Amazing concept. What it simply does is that in the example, I went to Bandra and inquired for the price, right? So what backpropagation does is that it adjusts weights and biases based on the accurate information, based on the actual truth data, right? So a number of epochs go back and forth, get trained, and the backpropagation then gives you most reliable answers, if not the perfect, most reliable, because the reason is that if it's giving you most reliable answers half the time, then half the time it is not going to be reliable. So that's how it works. But it will try to minimize the error as much as possible. And the third concept that powers the large language models is attention and self-attention. This is a concept which came in around 2018 by one of the researchers at Google. I'll talk about what is attention and self-attention, but this had turned the large language models into what we are known today. These are not just capable of language anymore. I mean, I wouldn't say language, but these are not just capable of text anymore, but they are capable of images, audio, video, and anything that you throw at it, as long as it is a content and that you are intending to generate, right? So in the previous example, the same one, can I predict the last word? Okay, what does it take for the prediction? So what I do is, all the words in the English dictionary, you just starting with A till the last letter in the dictionary. What you do is you just assign them in an alphabetical order, and plot them semantically, which are closer. Semantically, as in like software engineer, medical profession, ophthalmology specialist, so on and so forth. So these words are just commonly used words together, right? So that is semantics. So when you map like that, in the previous example, even if bed and red, they are in a very different order in an English dictionary, they'll still be able to be mapped together closely. Okay. Now these are called vectors. This is plotting the vectors on the scatter plot. So now what you do is you use artificial neural network like this with that particular sentence we are talking about and try to predict red. What happens then? Okay. Long sentence, right? Long sentence, and you are expecting the word read to be predicted. Can we decrease the length of the sentence to predict the word? Yes, we can. How can we do it? By paying attention to these three words and this word. Hair was still and bed. Probably this would give a proper prediction. So how does it do it? Okay, so how does it do it? Assume that you have, you are expecting the word red to be the suggestion. What it does is that it calculates the possible outcomes for each of the expected word. Okay, feeds it to itself, and then basically works with the next word predictor. The next word predictor would act like a labeled data which feeds, which tells attention network what is the word that is expected. Okay. Now this process goes on and on for a lot of epochs. Okay. And so when there is a word like this, still, it would consider the weighted summation of the probability of the words, and it will store aside. So it will basically calculate the weighted average for each of the words, and feed it with the attention prediction model. The outcome would be that if you start with the word it's, okay, it's is an attention. It's is a prediction. Of course, it could be the word could be something else, but when you select something else, a word something else, I mean, if you select a different word, the prediction goes in a different direction. But in this case, let's stick with it's then it's a lot. It's a lot of fun, so on and so forth. Basically, it's trying to retrain itself with the attention words, and then gives a prediction, right? That is one one capability. The other one is the universal facts. Now, universal facts are nothing but sun rises in the east and sun sets in the west. The first president of a country, so on and so on. These are universal facts. Can it be trained on these as well? Of course, it can be. Of course, all it needs is more and more data. How much more? Petabytes of data, right? So when these prediction and attention layers are stacked on top of each other, you'll gain as much reasoning capability as possible. 96 such layers are present in GPT-3, and Palm, which is released by Google, has 118 such prediction attention stacks. Okay, right. Finally, after all this painstaking example, what is the output? So we get something like this. You feed an image and ask what is unusual about this image, right? So what is unusual? Pretty self-explanatory, right? Someone is ironing their clothes on the back of a car. So this is a humor. And what is unusual about this second image? Right? I'm sure you must be knowing what is unusual about this. So it gives a step-by-step breakdown on what's actually normal and what's actually not normal. Okay? And the output, again, is something like this, right? You wouldn't possibly imagine a pope holding an assault rifle, right? Or a world leader sitting and having ice cream at the beach. But generative AI is capable of generating new data. Okay.
That's why. Oh. It's it's a little embarrassing. Reminds me. I was once in Russia. I ran into Gorbachev. He said, "That's why." Oh. It's that's why. Oh. That's why. Oh. It's
Okay. So that is Tom Cruise, right? He just knocked himself off and fell to the floor. Do you guys know that this is not the actual Tom Cruise, right? This is a deepfake video, okay? Similarly, there is this video which basically takes in a video as an input, and based on the text string, if I could play this real quick. Okay, so this is an input video and the text string is moving through a field of fire, right? And a deer on a skateboard. So when you are providing text strings like this to an image or a video, it basically implements those with the knowledge it had gained. Okay. Yep. So that takes us to the next part. I mean, it's all good and dandy, right? So far that it has amazing capabilities. It can do a lot of things. It can substitute a lot of manual tasks, so on and so forth. And let's talk about opportunities before we delve into the risk that it presents, right? You know, this is something that you guys are already aware of. The code completion, translation, language understanding, summarization, pattern recognition, blah, blah, blah. This is with regards to the text, and then it also can get into the domains of marketing and media, material design, so on and so forth. But what would make that possible? Because GPT-4 or any LLM by itself is not capable of it, because we are still using APIs to make the calls and all. Can we do it? Can we achieve enterprise level AGI using LangChain, right? This is one framework which is popular now, and what it does is it helps use GPT-4 or other large language models as an agent to create automated, to basically prepare or produce enterprise level applications. Okay. And of course, there is something else called AutoGPT. What it does is it basically is another type of agent which can automate a lot of processes and scripts, and if required in a loop. So using LangChain and using AutoGPT, we can achieve enterprise level AGI. Okay. Now again, I'm talking about some of the apps that are already available. I think I showed it in one of the previous slides, right? So now the industry-wide impact of AI. Now, as per Goldman Sachs, almost 26% of domains, 26% of jobs across all these domains are going to be across a major domains would be replaced by AI. So that accounts to about 360 million jobs worldwide. Okay, and this is just a percentage of adoption in some of the emerging markets and the developed markets. Okay, now we spoke a lot about how AGI works. What is AI? What are the opportunities? So the story doesn't end there, unfortunately. Why? Because like Yuval Harari said, he's the author of the book Sapiens. Wonderful book, by the way. What nukes are to the physical world, AI is to the virtual and symbolic world, which means that it comes not just with a tremendous opportunities, but it also poses greater risks in a lot of different ways that we are yet to comprehend. But let's get into that a bit later. This is Dunning-Kruger effect. What it says is that when it was released, when ChatGPT was released initially, people were like blown away by the capabilities. I mean, the way it held conversation, the way it answered your queries, it was amazing. People thought it was amazing, it was perfect. But then, as and when more and more people started to use, they understood that, damn, this is amazing, but it gives answers which are plausible, not the perfect ones, but they are plausible. Okay. When you ask, for example, very specific questions about any subject, you will notice that it will start to flutter, right? So then people would be like, okay, this is amazing, but it has its limitations. Then the next phase is, okay, now that I understood the limitations, these are the things that I can achieve. Okay. And then finally we are like, okay, now I know its limitations, now I know what it can do, I'm well versed with how I can use it. So that is simply the Dunning-Kruger effect, which simply talks about how something in the initial phase makes a strong impact, and then later you will understand how the purpose change. I mean the way it functions changes. Okay. Lot of news around LLM. These are a few which are encapsulated in these in the list of these risks. Classified into two: operational and social. Right. So in operational challenges, it is more about model interpretability. Interpretability is in the explainability. Right. Why does it suggest a particular word? Do I see a clear correlation? So that we are not able to do it right now. Data privacy, this is a major concern because the API calls go through the OpenAI's servers, so it can compromise the confidentiality of some of the data. Glitch tokens, development costs, operational costs, complexity, cybersecurity threats, corporate liability. So these are some of the risks, and there are social risks as well. The first one is job risks. Mayank was talking a little, was talking about having a pair programming with a robot, right? A little while ago. That can be a possibility. Much sooner than later, because the growth in the exponential growth in AI. Let me just give you an interesting fact. It was not expected to have AJ sort of capability. I mean, GPT-4 kind of a model is not expected at least for the next 5 years. Okay, but we already have it, and 3-4 months have passed. So that gives a glimpse of the AGI capabilities, right? Can an AGI, a truly AGI network come? Of course it can, but it also comes with risks like this AI hallucinations. Like, it gives you a story which has, or it suggests you a book. If I say, how can I improve myself at some task, and it gives you some list of books to read. The funny fact is that none of the books exist in real world. It just makes up things, right? So this can lead to misinformation, and it can lead to violence. It could lead to tremendous challenge like misinformation, which has been plaguing right now, right? Over reliance on AI. What is this? This is simply that the models which are trained on right now is all human produced content, right? Now when the model learns and gives you the suggestions, gives you the answers, gives you the data, translates, so on and so forth, the creativity is essentially curtailed. And as an AI, it can only learn from what is taught. It cannot think new, right? So that over reliance can kill creativity. Bias, amplification, and stereotypes. I mean, this is one major thing. Copyright issues, legal and ethical considerations. So these are some of the social and organizational risks. Here are a few points that I could gather to basically succeed at your workplace, which essentially includes education and training, clear AI regulations, guidelines and policies. Just yesterday, Sam Altman, the founder of OpenAI, had testified to the US Congress on the regulation, the risks that LLMs pose. So it's a pretty dynamic changes. I mean, it's a pretty dynamic landscape, right? AI governance structures, collaboration and feedback, so on and so forth. So these are a few pointers that can guide us in AI adoption on an enterprise level. Okay. So these are some of the interesting platforms that you guys can try. OpenAI, Stability. Some of these are already in use. Midjourney, for example. So we've used it in photo booth composable hero API. So so these are some of the apps, right? So any questions after all this long monotonic narration. Any questions? I'd love to answer some of your questions because this has been a very interesting subject of debate in the public domain.
Very, very good. Very, very good one, actually.
Thank you.
So, similar to that thing, actually. So what should we be doing, actually, from in content stack? How do we leverage this one?
Okay.
What are the like top 3 things that we can do to make our product better, help our customers?
Okay, so I think we need to have an approach which is AI centric. The way applications evolve, the way our product lines evolve, right? So they need to have AI in the middle, or have a strong AI feature that can enhance the capabilities, right? What we are doing right now is that we are adding the AI features to the existing workflows, but to make it like yesterday's demo, right, where we had this AI bot, which is a Q&A bot. There is one limitation to that. It is not conversational. If we can make it conversational, as in, I ask a question, how can I use a webhook? Okay, it says so and so we can. The next question is, can you give me an example schema? It gives that. Where can I go and try this out on my IDE? It gives an answer. So there's a coherent dialogue, a coherent conversation that's happening. If we can reach to that, I think we can really have an amazing app. But it is not just limited to this. I think with regards to images, with regards to a lot of even content model suggestions, this was one R&D that we were working on. So the AI centric thought needs to evolve in content stack. I think that's been happening in other organizations also. But once we have that AI embedded in our solutions, I think that can be game changing. I mean, again, this is a cost benefit analysis that we need to do. The risk factors like the data privacy, so on and so forth. But yeah.
Thanks, Shrikant.
That's all. No more questions.
Also, for people who are on the call, if we have questions for Shrikant, or if you all have any views on the session that we conducted today, please do let